Hello everyone, in this video we're going to talk about the law of cosines and how we can use this law to solve any triangle. So when we can use law of cosines is one of the two following. When we have two sides and the included angle, so that would be like side, angle, side, we can use the law of cosines. Or when we have all three side measures, and that would be like side, side, side. So if we look at our triangle right here, triangle ABC, once again the larger letters, the capital letters, those are at our vertices, and when we look at them in our formula or in our equation, that's going to represent the angle measure, okay? The lowercase letters, A, B, and C, those are opposite of the angles, and those represent the side lengths of our triangle. So just depending on what information is given to us, we have three separate equations here, but they all are the law of cosines. So the first one we have is A squared is equal to B squared plus C squared minus 2bc cosine A. So I know that's a lot, but let's kind of break it down a little bit. So if we have A here, we're doing the cosine of A, right? B and C are in here. This is addition, B times C right there, okay? Now let's look at the next one. B squared equals A squared plus C squared minus 2ac cosine B. So once again, if we started with B squared, we're doing the cosine of B. And if we have A and C being added there, we are multiplying A and C right there. And the third one here, we could have C squared equals A squared plus B squared minus 2ab cosine C. So if we have C out front, cosine of C, A squared and B squared, then we are multiplying A times B. So like I said, we could use this in one of these two scenarios, and we're going to look at an example of each of them. So a side angle side case and a side 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 case. So here's our first example. And notice this would be like a side angle side. So we are given two sides and we have the included angle. So we can start off by saying, okay, 34 is opposite of B. So I know my equation is going to say B squared equals A squared plus C squared minus 2ac cosine of B. And now we just want to go in and fill in our information. So we don't know what B is, so that's still B squared. A is opposite of side of vertex A, so this is 11 squared. Our other side is 14. Now we do 2 times 11 times 14 and cosine of the angle, which is 34. Now this is a lot. You can go ahead and type all this in your calculator at one time, but be careful. So I'm going to post a video of like an overhead view of what I do on my calculator, and I'll link that in the cards right now just to show you what it actually looks like as I'm talking through these steps. So for me, I like to go step by step just to put the most simplest equation I can into my calculator so I know we're not going to make a mistake. So here we have B squared equals 11 squared is 121, 14 squared is 196, and now in our calculator we can do 2 times 11 times 14. So we get minus 308 cosine of 34. Okay, so now I'm going to add 121 and 196, and we get 317 minus 308 cosine of 34. Now, right here, I'm going to go ahead and take the square root of both sides. So square root of B squared, square root of this long expression over here. So now we're going to get B is equal to, now in my calculator, I'm going to type in square root 317 minus 308 cosine of 34, and I'm going to hit enter. When I do this, it tells me B is 7.85, so I'm going to round that to 7.9. So that gives me my side length of B. Okay, so now we have all three of our sides. So now we can use the law of sines to help us find the one other angle, and then we can just subtract from 180 to get the other. Now here we have to be a little bit careful because the angle that we choose to solve for first is important. Because remember, if we're going to use law of sines to find an angle, eventually we're going to use the inverse sine feature on our calculator to give us the angle measure. Well, the inverse sign on our calculator only works for acute angles. So we want to choose the smaller of the two remaining angles just in case the larger one is obtuse or right, okay? So now, if I look at my two sides, 11 and 14, the smaller side will be opposite of the smaller angle. So I want to solve for angle A first, okay? So let's use sine of 34 over, and now, opposite of 34, we have 7.9. But really, what we should do is the square root of 317 minus 308 cosine 34 to get us our most exact answer. So down here, instead of putting 7.9, I'm going to put the square root of 317 minus 308 cosine of 34 equals, and now I'm going to do the sine of A over 11, okay? Now let's cross multiply. So we get 11 sine 34 equals square root 317 minus 308 cosine 34 times sine of A. And we're going to divide both sides here by the square root of 317 minus 308 cosine 34 to get our angle A. Okay, so now in my calculator, I'm going to do 11 sine 34, and I'm going to hit enter. Okay, now I have 6.15 and some change in my calculator. I'm going to hit divide now, and I'm going to do second, and I'm going to hit the square root, 317 minus 308 cosine of 34, and I hit enter. Okay, so now this tells me that sine of A is equal to 0.78 ... Okay, but remember, we're trying to find an angle. So now we need to do the inverse sine to get our answer. So I do second sine, second answer. So I'm taking the inverse sine of the previous answer, and that gives me 51 point, and we'll do 6 degrees. Okay, so now I can put that in for angle A. So this is 51.6 degrees. And now all we have left is angle C, and that would just be 180 minus 34 minus 51.6. So angle C, and we'll do 51.6 plus 34, 180 minus 85.6, and that gives me 94.4 degrees. Okay, so it was good that we went ahead and found angle A first, because angle C ended up being an obtuse angle. So that would have messed us up when trying to use inverse sine on our calculator. Okay, let's look at the next example. Now we have a side-side-side example. So we need to find all 3 angle measures. Okay, so now, just as we were a little cautious about when should we use law of sines on the previous example, because remember, our calculator, the inverse will not give us an angle more than 90 degrees. So let's think about the same thing here. Let's find the largest angle first by using the law of cosines. So the largest angle is going to be opposite of our largest side. So let's find angle B first, which means we're going to work with B squared equals A squared plus C squared minus 2AC cosine of B. And let's fill in our information. So B, the side B is 27, side A is 12, side C is 20. So minus 2 times 20 times, well, let's do 12 here. 12 and 20, and then cosine of B. We don't know what our angle is. Okay, so now let's simplify this a little bit. We can do 27 squared to get 729. 12 squared is 144. 20 squared is 400. And then we can do 2 times 12 times 20. We get 480 cosine of B. All right, so now let's add 144 and 400. So now we have 729 equals 544 minus 480 cosine of B. And now let's subtract 544 from both sides. Okay, so we do 729 minus 544, and that gives us 185 equals negative 480 cosine of B. Now let's divide both sides by negative 480 and divide by negative 480. And that gives me cosine of B is equal to negative 0.385 ... And now we want to use the inverse cosine to find our angle measure. Okay, so we do second cosine to do inverse cosine, and second answer to find our angle. And this tells me my angle is 112.7 degrees. Okay, so now that was angle B. So I'm going to add that into my diagram, 112.7 degrees. Okay, cosine, not A, that was B. All right. Now we can go back and use the law of sines to find our one other angle, and then we can subtract from 180 to find the other. Okay, so let's find angle A here. So let's use sine of 112.7, which is what we just found, over 27 is equal to sine of A over 12. And let's cross multiply. So we get 27 sine A equals 12 sine 112.7. Divide both sides by 27. And this will give us sine of A. So we can do 12 sine 112.7. And now we divide that by 27. And now this is 0.41. And now we want to do the inverse sine so that we can find the angle measure. So second sine, second previous answer, and that gives me 24.2 degrees. Okay, so for A we can say 24.2 degrees. And now all we have left is angle C. So we can say angle C is equal to 180 minus 112.7 minus 24.2. So angle C is, and we'll do 112.7 plus 24.2, and we'll subtract that from 180. And that gives me angle C as 43.1 degrees. Okay, so now we have solved the triangle because we have all three angle measures and we have all three side lengths. Okay, and so that's how you can use the law of cosines to solve any triangle.